Hey guys, it's your favorite reliability test guy, and I've created some really exciting content that I've added to my website. So check out the link above or in the description link below to download calculators and templates for reliability tests and validation. I'm also going to be creating some tutorials on how to use some of these calculators and templates. Today, we're going to jump into how to use the random vibration calculator, which you can find on my website. Let's go ahead and jump into it now. So here is the random vibration calculator. Let's jump over to the second tab here, which is key and definitions. So over here in the left table here, we have the keys. This tells you the color coding for the input field, which is the values you enter, and the output field, which is the calculated output based on the input values that you've entered. Over here, we have the definitions. So when you download this template, you can review these definitions and understand the values that you are entering or what's being calculated by the calculator. So let's move back over here to the random vibration calculator now. So here we have this table, which is the breakpoint table. This is where you put your frequencies and your PSD or G squared per hertz values. Once you enter these values, it auto calculates your slope or decibels per octave. Over here is the total GRMS calculation based off of your inputs. This is the total acceleration content for your test profile, or the square root of the area under the PSD curve. So this is auto-calculated based on your frequency and your PSD entered values, and the calculated decibels per octave or slope. So let's go ahead and do a quick example. I'm going to go ahead and clear these values out. And we're just going to put together a quick, simple profile here. So I'm going to enter in 20 hertz, 100, 1000, and 2000 hertz. So over here, I'm going to enter 0.001 G squared per hertz, 0.01, 0.01, and 0.001. So if you look over here at the graph, this looks a lot like a NavMat curve, which is a type of environmental stress screening test that's done on components and systems for vibration tests and screening. As you can see, it's auto-calculated your GRMS to be 4.76 GRMS, which is the calculated area, square root area under the PSD curve, or the total acceleration content for your PSD profile. And then under the dB per octave column here, you have your calculated slopes. So the slope between 20 and 100 hertz is 4.3 dB per octave. You don't have any slope from 100 to 1000 because notice your G squared per hertz or your PSD is the same value, and that's highlighted as the flat area of your PSD curve here. So there's no slope there, obviously. And then from 1000 to 2000 hertz, you have a negative 10 dB per octave slope from 1000 hertz to 2000 hertz as you go from 0.01 G squared per hertz to 0.001, as you can see here. And that's pretty much it. It's pretty straightforward, pretty easy to use, and I hope you find this useful when you want to run calculations and graph your vibration tests, random vibration tests breakpoints. All right, thanks guys for watching. Have a great day.